What is a Riemann sum? A Riemann sum is the approximation of the area under the curve. So, if you had a linear function, y equals x, this would be your graph, and to find the area under the function, you would find the shaded area. So, you already know the formula for the area of a triangle, which is 1/2 times base times height. So your distance from 0 to 5 is 5. So that would be your base. So 1/2 times the base of 5 times the height of 4 will give you 10. But what if you have a function like y equals x squared? So for regular polygons, you have squares, rectangles, circles, triangles, and you all have a formula for all of those polygons. But for the area under a curve, there is no specific formula to find the area. So what you do in this case is you would use a Riemann sum. To find the area under a curve, wouldn't it make sense if we used the area of something we did know, like a rectangle? So what a Riemann sum basically says is that the area underneath the curve is the sum of the area of the rectangles that fall underneath the curve. And this gives you a good approximation of the area, but it is an under approximation. And there are 4 kinds of Riemann sums that you can use. There is the upper, the lower, the right, and the left. And we will come up with some examples in a little bit. Let's take a look at this data chart. So this is the data chart for y equals x squared. So if we wanted to do an upper Riemann, then we would take the area of all the rectangles from the interval of 1 to 2, and 2 to 3, and 3 to 4. So the formula for the area of a rectangle is base times height, right? So we take the base, which is 2 minus 1, that's 1, and the height of that rectangle, and remember we are looking for the upper Riemann sum, so we take the highest y value. So that's 4 plus the width from 2 to 3 is 1, plus 9, because that's the highest out of 4 and 9, plus 1, and then the highest out of 9 and 16 is 16. So once we add that, we get 4 plus 9 plus 16, that gives you 13, and then you get 29 as your upper Riemann. So if you wanted a lower Riemann, you would do the same exact thing, except you would grab the lowest value, which would be 1, 4, and 9. You would not use 16. So you'd get 1 times 1 plus 1 times 4 plus 1 times 9, and that would give you 14. Now let's do the same for a right Riemann sum. So for a right Riemann sum, let's see, you'd have 1 times the right y value, which out of 1 and 4, the right value is 4, plus 1, and then the right value out of 4 and 9 is 9. And then the width is 1 from 3 to 4, and then the highest, well, the right value would be 16 out of 9 and 16. And then that would give you 29. And then for your left, you do the same thing, but only with the left values now. So you'd have the width from 1 to 2, that'd be 1, times the left value, which is 1, plus 1 times the left value, which is right here, 4, plus the width from 3 to 4, which is 1, times the left value, which is 9, and that gives you 14. Now let's go to some problems. So let's take a look at this example. We have an object that moves along a line. Velocity and time data are given in the following table. it's asking us to estimate the integral from 0 to 15 of v of t with an upper Riemann sum using 5 subdivisions of equal length. So this data chart, it has the time from 0, 3, 6, 9, 12, and 15. And the 5 subdivisions would be one from 0 to 3, and then one from 3 to 6, 6 to 9, 9 to 12, and 12 to 15. That's 1, 2, 3, 4, and 5. So it wants us to evaluate the integral from 0 to 15 of v of t dt. So since it's asking for an upper Riemann sum, we would take the highest y value for each x value. So for the upper Riemann, the width from 0 to 3 would be 3. So 3 times the upper value, the highest value out of 1 and 2 is 2, plus the width from 3 to 6 is 3. All of the widths are going to be 3 because it says right here that the 5 subdivisions are of equal length. So your upper value out of 2 and 5 is 5, plus 3 out of 5 and 18, the highest is 18, plus 3 times 18 and 26, 26, plus 3 times the highest value out of 26 and 39, which is 39. And when you put that in your calculator, you get, let's see, 6 plus 15 plus 18 times 3 plus 3 times 26 plus 3 times 39 gives you 270. So, using the correct units, interpret your answer from part A in the context of this problem. So, from time 0 to time 15. So, let's see. From t equals 0 to t equals 15 seconds, the total distance traveled by the object is approximately, do not forget approximately because Riemann sums are always approximations, is approximately 270 meters. Now for G, it's asking us for a lower Riemann sum using 5 subdivisions of equal length again. So that's 3. The lower value out of 1 and 2 is 1. Plus 3 times lower value is 2. Plus 3 times 5 plus 3 times 18 plus 3 times 26. And that gives you 156. Now on to H, a right Riemann sum using 5 subdivisions of equal length. So that's 3. Take the right value, doesn't matter if it's lower or less than the other value. So the right Riemann sum, that would be 2 plus 3 times 5 plus 3 times 18 plus 3 times 26 plus 3 times 39. And that will give you 270. And then for I, it's a left Riemann sum, so that's 3 times 1 plus 3 times 2 plus 3 times 5 plus 3 times 18 plus 3 times 26, and that'll give you 156. Okay, let's take a look at this one. I specifically like this one because it was on the 2015 AP Calculus exam that was taken only, let's see, 2 weeks ago? Okay, so Johanna jogs along a straight path for 0 to 40 minutes. Johanna's velocity is given by a differentiable function v. Selected values of vt, where t is measured in minutes and vt is measured in meters per minute, are given in the table above. So let's just do this part right here. Approximate the value of the integral from 0 to 40 of v of t, absolute value, using a right Riemann sum with the 4 subintervals indicated in the table. So these are the 4 subintervals from 0 to 12, 12 to 20, 20 to 40, and 24 to 40. And it's asking for a right Riemann sum, so the values that we'll be using are 200, because that's the right value on this interval from 0 to 12. And then from 12 to 20, the right value would be 240. 20 to 24, the right value would be 220, negative 220. But since it's asking for absolute value, we're going to consider that a positive 220. And then 24 to 40, the right value would be 150. So the integral from 0 to 40 v t dt can be approximated with a right Riemann sum. So the width of 0 to 12 is 12, and then the right value is 200, plus 12 to 20, so 20 minus 12 is 8, times 240, plus 24 minus 20 is 4, because that's the width, and then times 220, because remember, we're taking the absolute value, plus 40 minus 24 is 16, times 150. And then when we solve for that, we get 7,600 meters. So looking at B, it says, explain the meaning of the definite integral in the context of the problem. So from t equals 0 to t equals 40 minutes, Johanna jogs a total distance of approximately 7,600 meters. I hope you enjoyed this lesson, and goodbye.